Rota's back to life again.
We have a before and after map of the volcano, and we can see that there's huge changes.
Here at Ocean Exploration Trust, a lot of our discoveries are made after the fact when we're back off the ship. That's what we're going to talk about in this video. In 2025, EV Nautilus sailed to the Marianas Islands, one of the most volcanically, tectonically active areas in the whole ocean. And during our multi-beam sonar surveys, we got maps of a seamount called NW Rota-1. And it wasn't until back on land a couple months later that some of our geologists on the team took a look at these maps and realized there were some really interesting changes happening on this seamount. So today we're going to talk to them about their new paper documenting these changes and what it means for the volcanic and geological area of the Marianas altogether. Hi Bill, hi Jeff, it's so great to see you.
Jamie, good to see you again.
Thank you so much for joining us. We want to chat with you all about the paper that came out, and I want to reminisce about our expedition. But first, can you introduce yourselves to our audiences?
I'm Bill Chadwick. I'm a research associate at Oregon State University in Newport, Oregon, and I'm a geologist, and I study volcanoes and submarine volcanoes in particular.
Yeah, and I'm Jeff Beeson. I'm an assistant professor at Oregon State University in the College of Earth, Ocean, and Atmospheric Sciences. And I'm also affiliated with NOAA's Pacific Marine Environmental Lab. And I'm a marine geologist that does a lot of seafloor mapping and all things marine geophysics.
So we're here to talk about something that we witnessed on our expedition, but a story that started way before that, and a new paper that you have out that's kind of documenting that story. So we're talking about a seamount called NW Rota-1 Seamount. Is that correct?
That's right. It's got the number because there's 5 seamounts all clustered together, and this is the biggest one.
And that does take a quick step back. We're talking about one seamount in an area of the Marianas that is one of the most tectonically active areas on the planet, we could say. Could you tell us, just summarize, what do we know about this area, about the volcanoes, about the tectonic activity, and what's going on here, and why is that so important for the Earth in general?
What I think is so exciting about the Mariana and this particular volcano, or other ones in the Mariana Arc that we're studying as well, is that they give us this time scale window where we can see eruptions starting and eruptions stopping on a time scale that humans can interact with and investigate, where there are places on Earth where we really want to know about eruptive processes, but we have to wait either a really long time or they've erupted in the past and we're piecing together what's happening.
This seamount in particular, NW Rota-1, was the first place we ever saw a deep sea volcanic eruption on the planet. So it's pretty remarkable for that. This was back in 2003. We were looking for hydrothermal plumes. This seamount in particular had a very unusual chemistry to it, and it was because it was erupting. So it was just this incredible opportunity to witness that activity, and it kept going continuously until 2010. Soon after, apparently, it went quiet. Then there was another survey in 2019, still no changes, so it seemed like it had gone dormant. And then maybe Jeff can pick up the story when we were there with Nautilus.
Sure enough, on our way back to Guam at the end of our cruise, we transited over it, and there was a water column anomaly in the multi-beam data that indicated that there was at least some bubbles and some venting. And that got Bill, I remember going like, wow, yeah, okay, so something's going on at Rota. And it wasn't until we got back to Oregon and got the data and started processing it that we were like, oh, okay, NW Rota looks a lot different than it did last time it was mapped, which really kicked off this project that Bill, myself, and some undergraduates have been working on the past year or so on reprocessing the data we collected last year on the Nautilus and then comparing it and differencing it to the existing grids. And then that culminated in us writing that short paper on documenting the Rota's back to life again.
So we have a before and after map of the volcano, and we can see that there's huge changes. So there's a big new cone at the top. So the summit is now, is 550 meters before. It's now 450 or so. And then there's this lumpy ridge that's new that goes off to the west that looks like big, thick lava flows that have flowed in that direction. So that's really interesting because all the activity we saw before in the early 2000s was this mildly explosive, so fragmental, rocks and ash and so forth that would build up and then slide down slope. So we never really saw lava flows, but from the sonar data, that sure looks like it's been erupted lava flows. So it seems like maybe there's a new batch of magma that's come into the volcano. We won't really know until we can go back there and make some dives and collect some samples. And so we're really eager to go back, have any ship that's in the area kind of keep redoing this mapping so we can get more information about what's happening and when and kind of track its activity.
Yeah, I'll add to that just kind of maybe a bit more details on why Mariana is so unique and interesting. But this is some of the oldest crust being subducted on the planet. The age of the crust being subducted in the Mariana right now is 120 million years, roughly age.
I should mention the biological community a little bit because so Northwest Rota, before this new activity, it had a couple of shrimp species that are volcano specialists. So they're only found at active submarine volcanoes. As Jeff was saying, there was a cruise that was planned right around Christmas out of Japan that were able to make one ROV dive at Northwest Rota, and we were communicating with them. And we saw their video, and the shrimp are still there. So
Really?
there's this huge new addition of material. The whole top of the volcano has been buried by these new deposits, but the shrimp are still making a living there, even though the environment has totally changed and is dynamic and there's eruptions happening. So I'm very impressed with the shrimp.
Well, Bill, when you were describing those shrimp, I can't help but think that you might be related to those shrimp by being found at active submarine volcanoes everywhere. Maybe that's just where you live.
It seems like we learned so much from this single swath of multi-beam off of EV Nautilus that probably took no more than a day to collect. What does this discovery mean for the larger oceanographic community? Like, what do people have next lined up to study this area?
Well, Jeff and I obviously got very excited about that Northwest Rota was active again. So we've submitted a proposal to the National Science Foundation to try to fund a cruise to go back there with an ROV so we can go to the seafloor and see what's happening, see if it's still active, collect samples of all these new deposits to try to figure out maybe why it woke up. But yeah, we're also paying attention to what other research vessels are in the area, and if they have the opportunity to resurvey or even make a dive there, then.
And the way that Bill and I engage with our colleagues is not one where we're going to keep it hidden that Northwest Rota-1 is erupting, because there's so many aspects that can be gained by many people knowing about the activity, while we're telling our colleagues, and there's a student cruise on the RV Thompson. Well, maybe they'll go do a CTD over this and they'll get some interesting plume data. Or we have colleagues going to study some biological thing. Well, we can now give them a new map. We're not in the business of keeping it locked away as our little knowing what's happening. We send it out to the community, and then the community just gets excitement, and that seems to have been really positive responses and people wanting to go back and try to do work there.
I'd like to ask a question about the collaboration with this project. You mentioned before that you have quite a bit of students involved. So what makes this specific project great for that kind of student collaboration, and how have students been engaged in processing this data?
This was a great opportunity for students. Bill and I here at Oregon State University have engage a lot with undergraduates and graduate students in the oceanography and the geology, college, that because there's all this background information and background data at Northwest Rota and the Mariana in general, getting this new piece of data is a really, I don't want to say it's easy, it's straightforward. Like, we know how the methods and how to work with the data, but it does take time. It takes time to process the multi-beam data, to grid it in ways that are compatible with the previous multi-beam data. And then it has this processing component, but then it has this GIS how are we going to difference grid? How are we going to interpret, the spatial sides of it, that students really just eat it up, because there's all these levels of detail that, that Bill and I get to down the research path. But like fundamentally, it's like, how has the seafloor changed? And we have a map from before and we have a map after something happened. And we can look at how they are different and either looking at the volumetric calculation or looking at the morphologic changes. These things are intuitive enough with students where they can grasp it relatively quickly. And then Bill and I can, take them down the path of like, well, what does it mean? And that's where this has been really fun. And we've had some students that have been with us kind of from the very beginning when we got back with the new data. So they feel part of the project, that it's not some legacy data from a decade ago. It's like, this is right now happening.
Right. They get to be part of the discovery process, right? Like that to me, that's the funnest part of all this, is discovering new things that you didn't know were there, and they're super exciting. So the students were right in there with us while we were having the aha moments. So that was perfect.
Some of them have a little bit more time than Bill and I to make a figure or to process data, because it can take some very focused hours to do all this. And having a student get that experience is really fun. And then I get to take them out on cruises where they get to go collect data. So they get to see a full circle.
And it's interesting because at OET we do lots of different types of ocean exploration, and probably the fanciest, shiniest kind is the ROV exploration, where we get to live stream, and that's wonderful. But also people tend to forget how important seafloor mapping is. What do you have to say about the importance of maps to ocean exploration in general, or specifically to what you do?
This is a prime example that it was one transit line on our way back to Guam where we had the multi-beam on and running and collecting data, and it has spurred all this new interest in research activities and thinking about this volcano. That it really highlights that if you have the ability to have the system collecting data and you're moving a vessel around, like, you should have it on at all times, because you don't know what you don't know, and you need to have that seafloor mapping data to give you those next steps. That's true everywhere. You can't really start thinking about geology, seafloor processes, even in biology, without knowing what the shape of the seafloor is. And then because of this area's a really rich history of mapping from that Bill's been talking about, is that time series also is really important, because you can collect data in places that have change on these timescales. You can't even consider something mapped and then don't collect any more data there, because things change all the time on the seafloor.
It kind of used to be that way. I think when the multi-beam systems came out, I think people, let's go map the seafloor, and we get all this new high resolution views of the seafloor. And then each time we go out, we'll map a new place, which made sense. But in these active volcanic areas, things can change, and over just a few years. So this remapping of active volcanic areas has been a really important part of documenting this kind of activity. So things don't necessarily stay the same on the seafloor once you've mapped them.
Thank you both so much for talking to me today. Congratulations on this paper. I think we're all really excited to see what's next for Rota, what's next for the Marianas, and for all of the oceanographic community who are going to be out here hopefully studying and learning more about this and everywhere else in our global ocean.
Thanks, Jamie.
Thanks, Jamie.
We want to give a major shout out and a thank you to Bill and Jeff for joining us today to talk about NW Rota-1 Seamount and all of the amazing science that's going on there. Thank you to all of our partners and collaborators for making expeditions like this one happen. And while we might not be returning specifically to this seamount next year, we are going to be in the Marianas region again this summer, 2026. So join us and stay tuned, nautiluslive.org.